Tangible Trustworthiness for Mixed Initiative Network Defense, or T2-MIND. The image of the lone nocturnal hacker stealthily infiltrating global communication networks until daybreak is obsolete. Security experts for modern high-value networks, both commercial and government-owned, face an evolving threat. Hundreds to thousands of infected computers that work in coordination to overcome network defenses. This generates a tremendous amount of information. Cyber defenders must quickly decide what systems are currently vulnerable and which systems are no longer trustworthy. The efficient representation and understanding of such information is pivotal in combating cyber attacks. Current cyber visualizations can be overwhelming and stand in stark contrast to the natural, tangible components and physical representations used by commanders to plan within more traditional battle spaces. The T2-MIND interface allows for collaborative cybersecurity monitoring and utilizes novel displays and controls that allow the cyber defender to better interpret and utilize automated cyber defense systems. Each user can have multiple work surfaces in addition to the shared view of the network in the center. The shared surface provides information about relationships of the nodes in the network, including hosts, gateways, and subnetworks. T2-MIND uses the T2-IO framework for managing touch interactions. T2-IO is an open framework that defines a common protocol and API for tangible multi-touch surfaces. The T2-IO protocol allows the transmission of an abstract description of interactive surfaces, including touch events and tangible object states. This protocol encodes control data from a tracker applications and sends it to any client application that is capable of decoding the protocol. For T2-MIND, the tracker is an infrared camera that captures touch events on a surface, and a client application that projects interactive network visualizations onto the same surface from below. The enhanced tangible design used in T2-MIND allows for richer interaction than traditional network displays. Prototype tangibles were produced using 3D printers, paper sculptures, and modified off-the-shelf components. The tangible objects used in T2-MIND are not assigned to a specific function initially, but can be used by the network administrators to differentiate classes of objects from each other and indicate important functional assets in the network. By placing them on the display, an administrator can modify particular settings or flag a collection of hosts for increased scrutiny by automated security features. Nodes under suspicion by the user are given a heightened security status that slowly cools down over time once the user has stopped analyzing it. A user can flag a node as being highly suspicious by placing a tangible on that node, rotating it clockwise, and marking it as suspicious. Marked nodes do not cool down and retain a heightened security status. Users can highlight all nodes that are within range of attack from suspicious nodes and can change the threat range. In the individual work surface, users can see detailed information for flagged security threats. Violations detected by an intrusion detection system can be aggravated in different ways to detect incoming threats to the network, as well as the types of violations that are currently being detected. To review the details for a single node, a user selects the node in the shared view of the tangible object. When a matching tangible is placed into that user's individual work surface, the detail view is filtered. T2-MIND allows the user to define a network layout that makes sense to them. For example, the user can place important functional assets on one side of the display and move suspected threats to the other. A force-directed layout can also be used to increase network legibility. Tangible devices serve as anchors when the layout is changed, as these are important touchstones for the user's understanding of the current threat landscape and provide visual momentum between views. This creates a natural separation of distance that the user can then use to explore the path that an adversary might take when attacking the network. As the user examines each link along the attack path, she can see the nodes that could also be compromised along the route. Each affected node highlights in red to indicate that the system has heightened the security status of those nodes in response to the user's actions. If the user marks the asset as suspicious, it glows urgently to direct the attention of other users in the shared workspace. The user can further reconfigure the network display by collapsing and expanding subnetworks in the shared workspace. When collapsed, a subnetwork node displays the properties of its subcomponents. So if a subnet contains an asset, it retains the blue markings of an asset when collapsed. If a subnetwork contains multiple subcomponents with different properties, such as an asset and a suspicious node, the subnet aggregates the display properties so that the user will better understand what is inside it. When it is collapsed, the subnet will glow with the urgent display of a host that has been marked as both containing an important functional component and as a host that is suspected of malicious activity. This has been T2-MIND, a joint effort by Charles River Analytics and Tactable.